the best. Nigga, we the best, man. Listen. Hello guys, you're welcome to my page, and thank you very much for joining in. A lot of DevOps engineers have a very big problem. I also had that problem when I jumped into DevOps. The problem is that most DevOps engineers do not have practical real-time code to practice with. When DevOps engineers are working, they say they should deploy a website. They mostly always deploy a hello world website. They don't have the practical real-time website in real life to practice with it. So in this project, I have tried to use a real life code. This is a real life code, a real-time code that is being used, and it's being commercialized. I've used this code and I'm making the code available to you to use. The code is going to contain, we are going to deploy a 3-tier application. That is, we are going to have an application that has a database behind, and the application is running on AWS and EC2 instances, and then we are going to configure these EC2 instances to be highly available. So we are going to construct this 3-tier application, and we are going to build the infrastructure from zero right up to the end. So it is a very interesting project. I've not seen this type of project anywhere in YouTube, and I'm very happy I was able to come up with this project. If you are able to go through this project very well and understand the inner bits of the project, I bet you can add this project to your resume, and you will be very well appreciated. And if you can construct this, because so many people are going to the cloud now, and automation is taking over. But before you automate anything, you should be able to understand the manual creation of everything, okay, of all the infrastructure. So if you go through this project and understand this project very well, you are capable of understanding the manual infrastructure. You can then automate yourself. So this infrastructure is going to be on a private virtual a VPC, and it is going to communicate. Let's have a look on what our application is going to do. This is our application. In this application, what is it going to do? We are going to have classes. We're going to have classes, and we will be capable of adding a new class. We are going to be capable of adding a class like form 4 biology. We add, and we'll be capable of going to students, and we add a new student in each class. We can add a student. Let's select like the form 4 that we just added, and then we add a new student, which by name we'll give Ashu Nyenti as a name, and we save. And then we go now to attendance, and we click on form 4 biology. We have only one student there, and we go to attendance. We click on today. We see Ashu Nyente, and we say he was present, and then we save attendance. And then we can go to reports, and then we generate a report from form 4, and we select May, the month of May, and the report is generated. We see that everything works very well. The application is talking with the database, and everything is functioning very well. So this application can be used to control the presence of students in a particular school by class and by subject. This is an application that a school can actually use for the control of their presence sheet. So let's see how the application will be designed from base, and let's see how the infrastructure looks like. Come with me. We the best, nigga. We the best, man. So guys, this is the the graphic representation of what we are going to be creating. So I just want you to see what we are going to be creating here. We are going to configure an EC2 server, a server which we are going to call a control server. We are going to configure this control server, and then from this server we are going to generate an image we're going to generate an image of this server already configured, and then from this image we are going to create a launch template, right? We're going to create a launch template from this image, and then this launch template is going to have all the configurations of creating EC2 instances. Now we are going to link to the launch template a target group, and this target group is going to be linked to a load balancer. There will be two target groups, target 1 and target 2. Okay, the two target groups will be linked to an application load balancer, and below the target groups now we are going to have an auto scaling group. Okay, in this auto scaling group now we are going to put our instances. Why are we having an auto scaling group? Because this is a highly available infrastructure. We want a situation where when traffic gets higher, EC2 instances, they start adding automatically, and when traffic gets lower, EC2 instances, they start reducing automatically. That is what we are actually running behind. So we are going to configure this auto scaling. So the question is, why are we having two auto scaling groups instead of just having one to be adding instances and reducing instances? The reason we are having two auto scaling groups is because we want to make the structure highly available in such that during periods of update, the architecture, our service should not go offline. So during periods of updates, we can do blue-green updates or blue-green deployment, and we can also do maybe canary updating. We will see how we can be able to manage canary updates and blue-green when we use this infrastructure. So our auto scaling group is going to contain now our EC2 instances. Okay, this auto scaling group is going to contain our EC2 instances, and the EC2 instances are going to be in two different public subnets, but the public subnets will be available in different availability zones. This one will be available in 2A, and this one will be available in 2B. Okay, or 1A and 1B, whichever region you are. And then from here, all the EC2 instances are going to write to a common database. We are going to create two private subnets, but we are going to create our database in one private subnet. We are going to create two database subnets, two private subnets for the use of subnet group. We shall see what subnet groups are. So this is our full infrastructure, which we have to create from the base. We are going to create everything. Nothing is existing. We are going to create everything from the base. The only thing that we have right now is our application code that has been given to us by our programmers, and here is the application code that has been given to us by our programmers for us to deploy. Consider a situation where you have been given this application code by your programmers for you to deploy. Here is your application code. You need to deploy this application code. Okay, it is a website which actually performs some sort of roll call and take down the presence of students and all the like. We shall see after we must have installed. So we have our application code. We are going to create all this infrastructure. Now the whole infrastructure might be confusing, so what I did is I prepared a series of steps for you to follow so that you should not go astray. So here are a series of close to 20 steps for you to follow. We are going to follow all these steps so that when you are doing your own creation of infrastructure, you should not go astray. You should follow all the steps. The idea is not to cram the steps and follow them as they are. No, the idea here is to know what each and every step is doing and why it is doing that. If you are able to create this infrastructure and understand what each and every step is doing and why that step is there, then your architectural level for AWS has come to maturity. Okay, let's go and start creating our infrastructure. The first thing we are going to do is, they say we should create our VPC with 2 public subnets and 2 private subnets. Let's go do that. we come to VPC. Okay, here is our VPC. We are going to create one VPC with 2 public subnets and 2 private subnets. So we go to create VPC. Create VPC. We are going to name it student VPC. Student VPC, and we are going to give it the CIDR 10.15.0.0/16, and that's all we need to do to create our VPC. The next thing is we are going to create the first 2 public subnets. So create the first public subnet, and we are going to create that subnet in our VPC. The name of our subnet will be public subnet 1. And we are going to create this subnet in US 1A, US East 1A. And our CIDR for this public subnet will be 10.15.0.0/24. Let me copy all our data and keep, because we are going to need it for references. Okay, our first public subnet has been created, but we will need to, this one is public subnet 1. Now VPC should be /16. Now we are creating public subnet 2. Public subnet 2, which we are going to put it as, we'll put it as 10.1. So this will be our public subnet 2. Let's go create it. We are going to create it in our VPC, and we are going to give the name public subnet 2, and we are going to create it in 1B, and we are going to give our CIDR that we already prepared, and we create our subnet. Now these 2 subnets are not yet public, so what do we have to do in order to make them public? We have to go to the subnet, action, edit subnet settings, enable public, auto public assign, and we click on save. We go to public subnet 1, 2 and do the same. It's our public subnet 1. Here it is. Action, edit subnet settings, enable auto assign public address, and we save. Good. Our public subnets have been created and they are now public. So let's create the private subnet now. In our VPC, for our private subnet, what do we have as private subnet 1, we should definitely have something like 10.15.2/24 for our private subnet 1. Put it in our VPC, and then subnet should be private subnet 1. Reference preference should be private subnet 1 should be US 1A, and then our CIDR we paste here, and then we create our private subnet. Our private subnet is created, subnet 1 is created. Now we are going to create private subnet 2, which here we are going to change this to 3. Let's make it beautiful. So that you see the different changes. So our private subnet 2 should be this. We go to create subnet in our VPC, and this subnet should be called private subnet 2, and it should be in 1B, and we said our address should be 10.15.3.0/24. We create our subnet. Okay, now let us come to our diagram. We have created this VPC, we have created this public subnet, we have created this other public subnet, we have created 2 private subnets here, although we have but 1 private subnet that we are going to use, but for the sake of subnet groups we have created 2. Now the next thing is we need to create now we need to create an internet gateway and 2 route tables. We will need to have an internet gateway and 2 route tables to link to our VPC. So let's go create the internet gateway. We come down to internet gateway. Is that what is in our steps? Create subnet groups. Where are we even? We created VPC, 2 public subnet and 2 private subnet. We are to create now internet gateway and link to our VPC and create 2 route tables. Okay, let's create our internet gateway. This is our internet gateway. Create internet gateway. I call it student internet gateway, and I create it, and they say I should link it to VPC. So I have to link it to this VPC and attach internet gateway. Now after creating internet gateway and linking it to VPC, I say I should create 2 route tables and link one to the internet gateway and my public subnet, and the other I link to the private subnet. Okay, so when I created the VPC, a route table was created by default. This route table like this was created by default in that VPC. So instead of creating 2 route tables, I'm going to create 1 route table and add to this one. So I should just name this one route 1, private route 1, because I'm going to link this one to the private route 1, and then the other one I'm going to create will be private public route 1. It will be in our VPC, and then I'll create the route table. Now I have two route tables. They are private route 1 and public route 1. So for the public route table, I'm going to associate it to my public subnet. I associate, and then for the private route table, I'm going to associate it to my private subnet. Now, which of the route tables is supposed to communicate with the internet? Of course, it should be the public route table. So for this public route table, I'm going to attach it to my internet gateway. The route table that communicates with the internet is a route table that you route to your internet gateway. So I add routes here. I choose internet gateway, and then I send the traffic to the internet. I save changes. Okay, I've routed all my resources to the internet and set the private ones to private. So let's see where we are. We have created our two route tables. Now we need now to create a security group for our database. We have to create a security group for our database and open the port 3306 to our public subnet and port 22 to our Bastion server. Okay, we are going to create, before we create a route that these security groups, it will be good we create a Bastion server first. I propose, because here, where are we creating a Bastion server? Create a Bastion to pass through it so as to SSH to your database. Okay, let's create this Bastion, guys. Let's this step 0.9. Let us create it in, because we are going to create this security group, and this security group, we have to communicate this security group to our Bastion so that our architecture should be highly secure. Okay, so let us create our Bastion, and first of all, before we create the security group. Okay, so for our Bastion, we go to our EC2 instances. We launch our instance. We call it Bastion server. It is an Ubuntu server. We are going to use T2 micro, yep, and then we're going to use the same key pair that I already have, and here we are going to place our Bastion in our VPC, and we are going to place it in the public subnet 1. Public subnet 1. Yep. And for security group, now we are going to create the Bastion security group with our specifications. Bastion security group, and here for this Bastion, we are only going to allow SSH to the DB server. Let's actually name it. Let's be professional, guys. Allow SSH to the DB admin. That is the description. And for our Bastion, so we are only going to open our SSH, and our SSH is going to be from my IP. Let's consider that I am the one that is the DB server, the DB admin. my IP will be here. So if I'm not the one that is the DB admin, when I click my IP, it chooses my IP automatically. But if I was not the one, you click on custom and then you put the IP address of whosoever is the DB admin, his physical IP address of his computer /32. But since I am putting myself as a DB, so my IP arrives automatically. So my bastion is available to me on port 22, and only me alone can have access to this bastion on port 22. Okay. All right. Now I think everything is okay. I launch my bastion. Okay. Now that my bastion is well launched, the next thing now is create the security group for our database. Now our database is going to need a security group, and we should create the security group beforehand, so that when we are creating the database, we should just join the security group to the database. So we come down to security groups, and we create a security group. We call this security group Aurora. It will allow 3306 port to where, look at where we are. We are at this level. We want to create a security group for this database. So this security group that will cover this database should be open to this public IP address and this public subnet and this other public subnet. Okay, our security group should be open to this public subnet on port 3306 and this public subnet on port 3306, so that these servers can have access to the database. Guys, this is the most important concept in networking. If you fail to understand what is happening here, you don't understand the concept. So we are creating a security group around our database, and we are opening the port only to the subnet where our servers are situated. Okay, so let's do that. So our first security group will open the port to where? To our first public subnet. And what is the IP of our first public subnet? Is the IP of our first public subnet. We copy it and then we put it there. We choose it. Description, we say public subnet 1 access, something like that. We add another one, we put it still, it is Aurora, and we take the second public subnet, copy that, and we put here. Then we put it public subnet 2 access. Now we need SSH to this database, so we are going to add an SSH port 22 to who? We're going to add the SSH port 22 only to our database, only to our bastion. Only our bastion is going to have possibility of SSHing to this database. So what are we going to do? What should we do here in order to add it only to our bastion? We can either copy the IP address of our bastion, which is, let's go here now. Okay. let's go to EC2, and then we copy the IP address of our bastion. This is the address of our bastion. Now we come back here, we put the IP of our bastion, and then we say /32. So only our bastion will be capable of having SSH access to our DB. Guys, this is the most important configuration, that if you fail this configuration, you might have trouble with the whole of your architecture. So understand what this configuration is doing very well. Let me try to draw it for you. So we have our VPC here. Here is our VPC here. Now we have our private subnet that is here, and then we have our public subnet that is here. Okay, now for this public subnet, our database is going to be inside this private subnet. Our database will be here, but this database is going to be surrounded by a security group. Now we are saying that this security group should only allow access to, first of all, this should only allow access to this other subnet and no other subnet. So, and the access that is allowed to the whole subnet is what type of access? Is the 3306 access. That means you can only pass through 33, not SSH. Now the only access to SSH should be allowed only to a particular EC2 instance that we are calling a bastion. So we are going to keep a bastion here, and this bastion now have access. Who has access to this bastion? The only person that has access to this bastion is your DB, your database admin. Okay, so this is the only person that has access to this bastion. He has a physical computer here, so it is the physical computer that is going to have access to this to the whole of this system. Okay, mind my drawing. So this computer is going to have access to this computer, and then from this computer is going to have access to this database. Now, but there will be servers here. There will be servers here, and these servers also need access to this database. But the access that they need to this database is the access that is going to pass through 3306 port. That is why we open the port here, and because there are two public subnets, we open two of those ports to those two public subnets. In this situation now, our database in a private subnet is highly secured. I hope we understand this concept very well, because this is the principle of security behind a dynamic and a highly available infrastructure. I hope you grab the concept very well. Okay, so these are the two rules that we allow for communication from our database servers to our database, and this is the port that we allow for SSH from our bastion to our database. Okay, let's create security group. Security group name, we give the name DB security group, and we say allows 3306 from the two public subnets and 22 from bastion server. That is our description, so that we know what that security group is doing. The VPC, we place it in our VPC. Okay, and then the rules are there. We create a security group. Security group is created. Now the next thing we have to create is, after creating where are we? We are here at 4, create security group. Now we create subnet group for the database. That is where we are. We should create a subnet group for the database. To create a subnet group for the database, let's move over to the database console. So here is our database console. We go right down to subnet groups. You'll see subnet groups here. So let us delete this subnet group. We create a new subnet group. We call it student subnet group. Okay. Description, you can copy the same thing. And then our VPC, we know the VPC we are creating it is in the student VPC. And then availability zone, we are working in US 1A and US East 1B. Those are the two availability zones we are working with. And subnets, okay, this is where we are going to select the various subnets which we are creating. We know we are creating a subnet group of 2 private subnets, so we select our 2 private subnets. We know that we started with 00 at the public, so 00 is a public and 10 is a public. So from 2 and 3, those are private subnets. So you select your private subnet. If you cannot figure out your private subnet, you come here, come to where you are saving your data, and look, 15.2.0 and 15.3.0 are my private subnet. So that is why I've taken 15.2.0 and 15.3.0 as my public private subnets to form a subnet group. So here I create my subnet group. So my subnet group is created. Now I can start creating my database. Now let me create my database. I'm going to use MySQL to create a database. And for MySQL, I'm going to use the latest version engine. And I'm going to use the free tier because this is a demonstration. Then we come down for database name. I'm going to put student DB, and then I'm going to leave the master username as admin for easy purposes. Master password, I'm going to put, so let us be putting down what we are writing, what we are giving them. So we have put database name as student DB, and we have put the master username as admin, and now we want to put the password. That should be, I'll put training 123 as password. So let's arrange it in this manner. And the last thing we will need also will be the schema. That is the table name, the default table name, which we'll call the schema, which we are going to find from the code that will be given to us. The code will give us the schema. So let's go and continue. Password, master password, we said it should be training. So in order not to make any mistake, let's copy it from here and we paste it here, and we'll paste it here too. We're sure that we didn't make any mistake. This is basically all about the configuration we need to do, except to come right down and see existing VPC groups here. Now you look at it here. When we decided to, when we were going to choose this VPC, our VPC should be chosen here, yeah, up here. When we are going to choose this VPC, automatically it is going to select our subnet group. This is a subnet group that we just created with our two private subnets. Okay, the reason why we created two private subnets is so that we should have a group. In creating a database, they need a subnet group, and for you to have a group is a combination of at least two. So we created two private subnets so that the two private subnets should form a group. So that's why we created those two private subnets, but we are going to use only one. That is why in the diagram you have just one private subnet, but we have created two. We created the two so that they should form a group, and for that group we are going to create a subnet group for that. Okay, now we don't need public access to our database. And existing VPC security groups, yeah, we created a security group which was the DB security group, and we are going to use that security group here. For availability zones, we know that it is 1A. It should take a preference. Yeah, let it just take a preference. We don't have any preference for that. Let it just take any one that it wants. And pretty much about it is just configuring what we already know. So for this additional configuration here, this is where we are going to put our schema. So when programmers develop a program or an application, they create a database of that application. They create tables, already prepared tables of that application. So if a programmer gives you an application code, you as a DevOps engineer, you have the right to ask the programmer, okay, where is the table code? There are two things that you actually need. So where is the table file? Here, this is a table file, sample attendance DB. That's the table file. Okay, that's the name of the table file. And there is also a script that tells you how to connect to the database. This script, it will give you the option of putting all these specifications that you gathered here, the specification of username, training, password, and all the like. Okay, so in our own case, our code has the name simple attendance DB. Okay, that's the name given to our code. And in order to actually understand this name, let us see what is happening here. Okay, let me open the code in let me open the code in Visual Studio. So this is the code in Visual Studio. So in this code, they are going to ask us all this information here, all this information that is given here. They are going to ask it to us. You see here is the code, PHP attendance. You can see this is a file to connect. This file, like this db connect, is a file to connect. So the file will ask you for the host. This host will be the endpoint for our database, the username which we are going to provide, and then the password which we just created when we are creating the database. And this is what we are talking about. They tell us that the name of the initial database file that is available, where all those databases, those tables are defined. The name is called sample attendance DB. So it is this name that we must use here in order to link our database to our application. Okay, so this aspect too is very, very important. So after all that is done, I think you are okay to go to create your database. So the database will take some time for it to be created. While our database is getting created, it will take some time for this database to come online. So let's see what we can be doing. After we must have created our database. Okay, after we create our database, they say we should create a GitHub repository and push the code to our GitHub repository. So let's go over to our GitHub repository. I have my repository open here. I'm going to create a new repository called student. And in this repository, let's create a repository. Now they say I should create a repository and push the code to the repository. So here is the code open in my GitHub. The code needs some specification for me to be able to push to my GitHub. So what are those specifications? It needs that I should have the host. The host, which is, what is the host? The host is the endpoint of your database. All databases will provide you this endpoint. Okay, some people will call it host, some people will call it a server host and whatsoever name, but the host is the endpoint. It is actually the endpoint to your database. I need it, and our database is still under creation. When you come to our database, it is still under creation. So we cannot have our host right now, or our endpoint right now. And then the second thing that we need is the username. We already know that the username that we gave to our database is admin. And then the third thing that we need is the password. We gave training123 as our password, so our password is already there, training123. And then the last thing we need here is the DB name, where we have sample attendance as our DB name. Okay, so the only thing we are waiting for in order to push our code is the host address, and that host address will be supplied to us by our database after the database has been created. Okay, so while we are waiting for the database to be creating, let's see what we can do. They say create your sample EC2 server and clone the application code from the GitHub repository. Okay, let's be creating our sample EC2 server. We go to, let me click that's this. We go to, so what is our sample EC2 server? Take a look here. This is what we call a sample EC2 server. This is the sample EC2 server. This EC2 server like this. We are going to create this EC2 server, and then from this EC2 server we are going to clone the code that is available in GitHub that we have sent to GitHub. We are going to clone the code and configure this server and make the server connect to the database. And when everything is working here very well, we are going to then make this server an image and keep here, and then from this image we are going to continue our architecture. So let us create this EC2 server. We call it what? Here we are. Create sample EC2 server. It is a sample actually. So we create it. Sample EC2 server. Ubuntu. use the same key pair, and then we put the EC2 server in our public subnet. First of all, put it in our VPC, and then we place it in our public subnet 1, and for our sample EC2 server, we can open a security group that is open to all networks. Okay, for that particular server, we can create a security group that is open to all networks, all ports. Let me call it universal security group, all ports. And copy the same thing, paste here. I think we are good to go. So our servers will have the universal security group. All our web servers will contain that universal security group. So I'll launch our EC2. Okay, our EC2 is certainly ready. Let's see how our database is doing. Our database is up and running. So what do we need from our database? We need an endpoint. So let us click here to get the endpoint of our database. Here is the endpoint of our database. We get the endpoint from here. Then we can put it in our code. That is, we put our endpoint there. Now we have everything necessary to push our code to our repository. Okay, but before we do that, we should save the code. You save the code very well, and then the first thing you do is, don't forget, git init. You initialize your repository, and then you do git add everything that has been modified, and then you do git commit. I'll just put it first commit. Now the code has been committed. Now in order to link it to my remote repository that I just created, where's my remote repository? This is the command I need in order to link it to this remote repository. This command like this. I copy this command, come here, paste it there. Now my local repository is linked to my remote repository, so I can push the code now. So git push -u origin main. Okay, the code has been pushed to my remote repository. So I refresh my repository, and I see that the code was pushed 1 minute ago, or less than 1 minute ago, whatever. Now the code is pushed to my remote repository. So that means I can now, from my remote repository, download, clone the code directly to my EC2 instance that I just created. So I just created my sample EC2 instance. Let me connect to my sample EC2 instance. Okay, and then I come to my sample EC2 instance. I should connect from here. I can get my SSH from here. Okay, So the first thing I want to do is I want to upload my privileges. Now I'm going to install PHP because the code that we are having is written in PHP. This code like this is a PHP code. So I'm going to install PHP. I'm going to install my SQLi Connect, and I'm going to install my SQL server. So this is the code for me to install all those things. I'm going to install, this is the code. It's a small bash script that I've written. I'm going to install PHP. I'm going to install PHP MySQLi, and then I'm going to install my SQLi server. These three things I'm going to install, and then I'm going to restart Apache. So this is the small script that I want to create to do all these things. So copy, I just create a small shell script. And then I execute my shell script. So my application is getting installed, and I have to do this also to the Bastion because I'm going to be using the Bastion in order to connect. So let me get to the Bastion 2 and do the same thing. For the Bastion, I'll open another window. I update my privileges. I create the shell file. I paste the script. No, I had a different thing on my copy. So I look for the script. Here is the script. Now I execute the script. So I go back to my control machine. The script is executed. So I have to remove the default index.html. So I have to go to and I remove index.html. Okay, and then let me give all privileges to all the groups to this particular folder. Okay, we are good with our server. We can now clone the code. So we move to HTML. We move to this directory. There is nothing in this directory, so we write git clone, and then we go and copy the code from our clone the code from our Git repository, a new repository that we just created. Take it from here and we paste it here. Our code is cloned. We write ls and we can move to our code, and then we see everything is available there. Okay, now our application is deployed, but there's one thing we have not yet done. We need to connect to our database, and then we transmit the database information. Here they say connect to your database using MySQL Workbench and transfer the app data tables. So that's what we're going to do. These are the data tables of this application. The data tables are here in DB. Here are the data tables. So we are going to take this file and send to our database. Okay, let's first try to see if we can establish a connection to our database. We use Workbench. You install Workbench, manage connections, now new connections, and we give our connection name, which will be student connection. Then we are going to use standard TCP over SSH. That's why we created our bastion. We're going to use our bastion as the SSH bastion to get to our database. So here we are going to give the IP of our bastion. Here's our bastion. Here is our bastion. We give the IP of our bastion here. And the username is Ubuntu. We are using Ubuntu machines, and we are using a key pair rather than a password. So let's go to our key pair. The key pair I am using is located in this folder, and the key pair is called France-V. The key pair is there. So MySQL host name, this host name is the endpoint of our database. Where is our database? It is this endpoint. Let us keep it somewhere. So our database name, password, schema, and then database endpoint. So this is the database endpoint here, and this is what they are demanding from us here. And then the port is 3306. We leave the port like that. The username, we said the username was admin. You remember? Here is the username here. We said it was admin, and the password is training123. And the schema, I'm going to put all of that for the schema. Here is the name of the schema. Okay, so we come here for the name of the schema, we put it there, and the password should be training123. Okay, let's hope we did everything correctly and we test connection. Good. Our connection was successfully established. Now that our connection is successfully established, let us close and then connect to the database directly. So here is now our student connection directly here. We click on OK here. Our Workbench will be attempting to connect to our database now. While our Workbench is attempting to connect to our database, the connection is established. Let us import the data. You come to administration down here. You come to import here. And then you come to import from self-contained file. you come, navigate to where your project is. My project is in learning projects, and there is a source code, and I have PHP. It is in DB, so here is the file. Okay, and then I select the file default here, simple. And then there is import down here. It is not very well showing. Import is down here, so you click on import down here, and you give it some time for the tables to get imported. Okay, once the tables get imported, you verify again your instance. Where is your instance? Your sample instance. Verify its security. Sometimes when you configure the security groups, they do not take effect directly. You verify that all your inbound and outbound rules are there. Remember that we authentify this one, that it should have all access, but we are seeing only TCP access, so we said we need all access, all traffic from anywhere. Okay, all right, that's that for our for our sample EC2 instance. So in order to check whether our application is up and running, we take the public IP of our EC2 instance, and then we verify our application by putting /student. Okay, our application is live and active. So this application, what does it do? We have, this is our home. We have classes. Here there are classes. You can delete the classes. Yeah, and you add your new classes. You can add like class name. Let me use the convention in Cameroon. Form 1, you save. It should be class name and subject. Form 1, biology, you save, and then you add another one. Form 2, biology, yeah, you save, and then you add another one. Form 3, biology, 3, form 3, biology, and then you save. So you see, our application is actually communicating with our database. So if we go now to students, we might have a new name. We say student, we search from the class. These are classes that we added to show that we can communicate to our database very well. We put a student like 1U clearance in form 1 biology, and then we save. And then we add another name like in form 1 biology, Paul Tasang, and then we save, and then we add another name like from 1 biology, Paul Bia, we save, and then these are all names in our classes. Then we come to attendance here. we can now select from here and say from 1 biology, on which particular date, on the date of today, and then we say okay, who was absent, who was present. Say Paul Bia was absent, and Paul Tassang was present, right? And maybe 1U clearance was present. Okay, then we save, and then now we can generate our report. After we must have saved, we come to reports, we generate report from 1 biology, and who should be there on May, the month of May. We have now the presence. We have Paul Bia absent, Paul Tassang present, 1U clearance present. So our application is communicating very well with our database and functioning very well. So we have everything needed to clone now our machine. So we come back here. They said let us go to what we were told to do. They said test the connection and make sure everything works, and we have tested the connection and we made sure everything works, right? We are in number 12. Create an image from your sample EC2 server. So we have to create now an image from this sample server. We click on the server, we go to actions, we go to image and templates, create image. For the image, we say the image is my server image. Image creating servers. Okay. The volume is 8, is okay for our demonstration. Everything looks good. I come down, pull the cursor this way, and I see create image. Okay, that image has been created for us right now. Since that image has been created, we don't need the sample EC2 server anymore. We are going to delete it, but before we do, let's see where we are. We have created the image. We have to create an SNS. An SNS is a messaging system that whenever one machine gets created or destroyed, an email will be sent to us. Okay, that is what SNS does. So we are going to configure this system to be a very smart system. Whenever a machine gets created, a message is sent to us. So let's go create an SNS. We go to topic called SNS, simple notification messages, and then we start from overview. We first of all go to topics. We create a topic. A topic should be a standard one. Name of topic, server management, call it something like that. Display topic name, this is the name that will be displayed when an email arrives to your email box, and our topic is created. And now that we have created the topic, we create subscription. Let's delete this one. We create a subscription from our topic. Protocol should be email. You can also make SMS, but SMS are paid. And I'm going to put my email address, which is clemerance@yahoo.co.uk, and then I'm going to click on subscription. Now when I go to subscriptions, I see that it is still pending. So let me come to my email. You will see there is an email for me here, server management. I have to confirm that subscription. I confirm the subscription. Now I go to my server management. I refresh. To see that instead of pending, the status is confirmed. So I have created my subscription. Okay, after creating subscription, what do we have? We create a launch template from the image that we created earlier. So let's go to creating launch template. Launch template should be in EC2. We create, this is launch templates. Create a launch template. Okay, for this launch template, template name is server templates. Server template. Template version. Let's put it 1.0. It is going to serve us for auto scaling, so we click that. And the image for that for that template should be the image that we just created. Here is the image down here. If you have multiple images, you can select from the drop down, but we have created just one image. So here is the image here. Okay, we go to instant type. We'll select T2 micro is okay for us. And then we come to key pair. Our template, all our machines will be created using this particular key pair. And then subnets. For subnet, our templates is going to be created in let's not include subnet in templates for now, because we are going to decide where the template is going to create in our auto scaling. Okay, so let's not put that. As for security group, let's choose an existing security group. For this security group, we are going to take, remember we created a security group and call it universal security group all ports. Okay, so this security group is going to be the security group that is going to shield our template, because these are savers, so they can be accepting all networks. That is just for demonstration issue anyway. And then I think everything is okay. Our volume is okay. We can create our template right now. Okay, our template is created. The next thing after creating our template, we are going to create a target group, two target groups actually, target 1 and target 2. So let's go create our two target groups. It come down here under load balancer. We should be seeing target groups. This is target groups. So we are going to create target groups. The first target is instances. We are going to add but instances to our target groups. The first name should be target 1. I think that's all you need to configure there, and then you put it in your VPC, and then that should be all there. You go to next, and then you don't add anything here. You just come down to create target group. Good. Your target group has been created. Target 1 is created, so you create the second target group. Come to target groups. create target group, the same thing, instances. The name of your target group should be target 2. Put it in your VPC, and then next. Good, we are here, create target group. Okay, now where are we standing? We are standing at this level. This is what we are creating right now. We are creating this target group. Okay, we have created this launch template, so we are creating this target group, and we are going to link this launch template to this target group. Okay, we'll see how we'll do that. All right. Okay, the next thing we should do is create a load balancer and attach to the 2 target groups. So let's go create our load balancer. Now, load balancers, create load balancer. We are going to create application load balancer. You create your application load balancer. This should be called student load balancer. Okay, it is internet facing, IPv4. It should be in our VPC, and it should serve US 1A and US 1B, and make sure it should serve the public subnets. Take care of details, and then come down. Your load balancer should be in the security group where your servers are, so it should be in this security group. And then the port where your load balancer should be listening, the first one should be for this target 1. When you add target 1, you go down and you save. Create your load balancer. After the load balancer is created, you click on your load balancer, and then you go to actions, you go to edit, add listeners, and then you come down to, no, you are not going to add listeners here. Have our load balancer been created? Let's check. It is still provisioning. Our load balancer is still being provisioning. So we click on our load balancer, here is our load balancer. Come right down to HTTP port 80. This is where you are going to do your editing. Click on HTTP port 80 because you want to add the 2 target groups on the same port number so that they should not fail. Then you come to actions, edit listeners. Yeah, this is where you are supposed to edit now your listener. You see that we are remaining in port 80. If this port changes, then you are not doing the right thing. Now you can add target group, and then when you select from here, you see target 2, and then you're going to save changes. Okay, we have added the 2 target groups to the 2 sides of our load balancer. So where are we standing? We have added these 2 target groups. Okay, so the next thing now is we have to create an auto scaling group and attach the auto scaling group to from our launch template. and then link it to all our load balancers so that our application gets, our instances start getting created. So let's go to auto scaling. Here is our auto scaling groups. We create two auto scaling groups. So the first one is create auto scaling group, auto, let's just put it first, auto scaler, and then we come down, we choose our launch template. It is a launch template that we created. Allow it at default. Next. Now instant type requirements, everything looks good there. In our VPC, we have to take our VPC, student VPC. Availability zone for this auto scaling, we have to choose the first availability zone. Let us take public 1A for this particular auto scaling group, and public 1B. This is public subnet 1B. Okay, we continue, and then they are asking us to load balance. We say we have an existing load balancer that we created, and from this load balancer that we created, we are going to choose from our target groups. So we link the first autoscaler to the first target group. Then we continue right down. That should be all for now. The moment I'm going to create this auto scaling group, instances are going to start being created automatically. Okay, so our desired capacity is 3, our minimum capacity is 2, and our maximum capacity is 5. Let's just put it like this. You can put any amount of number that you want. That means at all times we would like that we should have 3 machines that are available, but if traffic is really low, we should have 2 machines minimum, and when traffic gets very high, we should scale up to 5, but you can scale up to 100, 200 as you want. Okay, we're just putting this for practice purposes. Okay, when you put that, you come to next, add notification. Remember that we created an SNS topic, so we are going to choose now that SNS topic here, and then let us just put launch and terminate. Each time a machine is launched, a message is sent to you. Each time a machine is terminated, a message is sent to you. Okay, we put that and we go ahead. Next, for tags, we are going to name, and then we put the value as first autoscalers. This is the name that is going to be in the in your savers. So all the savers that are in the first autoscaling group are going to be called first autoscalers. Okay, and then we next, and then we review everything, and we create. Okay, our first auto scaling group has been created. Let's create now the second auto scaling group. Second auto scalers. As we created that first auto scaling group like that, instances are already getting created in our dashboard. We'll see it. Launch template, we are going to use our launch template still, and next we are going to go to our VPC. Here is our VPC and our availability zone. we're going to choose the public availability zones. That is where our servers should be created, the 2 public availability zones, and we are going to go to next. We are going to attach an existing load balancer because we already created one, and here we are going to choose target group 2. Then we go down, all seems good. We go to next. For this one, we have the same thing. Desired capacity is 3, minimum capacity is 2, maximum capacity should be 5. I said you can choose any amount that you want. We go right down, next, add notification. We have our notification that we created. Let's put terminate and launch to send us notification. Next, tags, we give the name and we say it should be second autoscalers. Let's just give the name of the web servers like that. Next, and then we verify and we create. So let's see if the instances have been creating as we predicted. Let's go to instances. Okay, we discovered that our instances are getting created. You see, these are instances that are getting created. We have sample EC2, which we are going to delete because we do not need this one anymore. So second autoscalers is what we just created now. First autoscalers have been created. You can see there are 3 second autoscalers and 3 first autoscalers. So that means we have, what do we have here? We have 3 first autoscalers and 3 second autoscalers. Okay, so these 3 machines have been created for us. Okay, now these 3 machines that have been created for us, can we have access to these 3 machines? And how do we have access to these 3 machines? Normally, for us to have access to these machines that are being created, we will now make use of our load balancer. So all the machines are available via the load balancer's DNS. So if we go to our load balancer and we ask for the load balancer's DNS, here's the load balancer's DNS, and we take the load balancer's DNS and we use here /student . We will discover that we are having direct access to our application. Let's see if what we did at the first server actually end. We'll go to classes. We'll discover that we still have our normal classes as we had it, and we go to attendance. We'll discover that we still have our report. We'll discover that everything is as we configured. That means we have created a system which we are no more having access to that system by our IP addresses or whatsoever. We are making access using our load balancer, and our database is functioning very well and everything moves very swiftly. Okay, we continue. Where are we right now? We are at this level. We have created our auto scaling. Now we need to create CloudWatch alarms. Okay, now we just created that maximum capacity is 5, minimum capacity is 2, and desired capacity is 3. So but what will make these instances to delete and create themselves automatically? That is what we want to configure CloudWatch to do. So for CloudWatch will then configure and tell the instances when to get deleted and when to get added. So let's go configure CloudWatch. So we come over to CloudWatch. You take your CloudWatch. When you are in CloudWatch, you click on in alarm. Now you go to create alarm. You select your metric. When you select your metric, you take EC2 by auto scaling, and then you always choose from CPU utilization. So we want that when our CPU is utilized to a particular maximum level, another instance get created. Let's select CPU utilization metrics, and then we come to greater than. So when our CPU utilization will be greater than 75%, that is what we are saying here, greater than or equal to 75%, next, what will happen? An alarm will be generated, right? Let's select our existing alarm. An alarm will be generated for us, and a message will be sent to us that there is an exceeding amount of EC2 utilization. Here the name of that alarm will be greater than. Let me just say CPU utilization is high. Okay, and then now we create that alarm. Now when we verify everything and then we create. Now when it is low, we have to also remove the machine. Remember that we are not only creating when it is high or when it is getting increasing, we're also reducing when the traffic is getting low. Okay, matrix EC2 by auto scaling. And we are going to take CPU utilization and select. Greater than. No, here will be lower than, and here will be 25%, and we go to create, and we choose our SNS topic, and we come down to next, and then we come down to less than. Then we say CPU utilization is dropping. Next, we verify everything and make sure it is okay. Then we create alarm. So we have created alarms. Let's look at all alarms. We have created less than alarms for CPU utilization, auto scaling, right? We have created less than, we have created greater than. Okay, now let us attribute these alarms to our auto scaling. Let us attribute this alarm to our auto scaling. Our alarm is still getting created. In order to attribute this alarm to our auto scaling, we go back to our auto scaling. Okay, we click on our first auto scaling, and then we come right down. We say automatic scaling. Click on automatic scaling. When you click on automatic scaling, you come right down and you click on create dynamic scaling policy. Now you take type as simple scaling. Scaling name, this one should be greater than, and CloudWatch you take greater than. Now you come down, you say when CPU utilization is more than 75%, equal to or more than 75%, add 2 instances. Okay, you create. That was for greater than. Now you still create another dynamic policy, simple scaling. This one is less than, and then you come to CloudWatch, you take less than, and then you come down here. Take note, take action. Here is remove. Whenever CPU utilization falls to less than 25 or 25%, remove 2 instances. We'll create. That one was for the first autoscaler. We go to the second autoscaler. We do the same thing. Come to automatic scaling, and then we come down to create dynamic scaling. Take simple scaling. Scaling policy is greater than, and the CloudWatch should be greater than, and when it is greater than, create 2 instances, and we add. We still come down to create dynamic scaling policy. Take simple scaling. Scaling policy should be less than, and CloudWatch should be less than. Then you come down to remove 2 instances when it is lower. So we have configured our system now that our system is fully smart now. It knows that when CPU utilization is more than 75%, when all these computers are used up more than 75%, 2 extra computers are going to be created, and an alarm will be triggered, and a message will be sent to our various emails wherever you are. So you can go to my email and let's see if messages have been sent while we were configuring all this. So you see, these are messages that were being sent as EC2 instances were being created. So all these messages have been sent to me while our EC2 instances are being created. If we destroy the EC2 instances, messages will still be sent to me that EC2 instances are getting destroyed. Okay, so our system is smart, our system is highly available, and our system is dynamic. Okay, now where are we standing? We are standing at this level. We have created CloudWatch alarms to control the scaling. Now create auto scaling policies that respond. Yeah, we have just finished creating the auto scaling policies that respond to our CloudWatch configurations. Now it is a moment for me now to show you how blue-green deployment is achieved. Okay, to show you what is blue-green deployment and how it is achieved. So come to our infrastructure here. In this our infrastructure, we have 2 auto scaling groups. So the idea behind blue-green is that let us block traffic from going to one of these auto scaling group, and when traffic is no more entering to this auto scaling group, we can now change the template of this auto scaling group and update all these machines in this auto scaling group. And when we update all these machines in this auto scaling group, what do? We block now this auto scaling group, and then we leave only the new auto scaling group that we have configured. And while this one is blocked, only this one is saving. And now when this one is saving, we can now update this one. When we update this one, and everything seems nice. We open both traffics now, and everyone receive all the two sides are receiving traffic. How can you configure all that? How can you achieve all this? Now that is blue green. For canary, the old application will be there, but you block this one and then you update this one to the new application, but you allow just a minimum percentage of traffic to be flowing here, not much, just a minimum percentage of traffic to be flowing here. Some people will get the new updated version, some people will not get it. So when those small set of people that are getting the new updated version are not complaining, that is how you keep increasing traffic. So how do we control all these things in AWS? How do we control all that? There is the target group that we configured. We configured a target group. Let's go to our EC2 instances, and let's just go to EC2. So we have come down to load balancers, and then under load balancer you click on your load balancer. Everything is done at the level of the load balancer. When you click on your load balancer, you come to your HTTP port here, and then you go to actions, edit listeners. It is the listeners that do all the magic. The listeners do all the magic. Look at here, we have a 50% traffic flowing to target 2 and a 50% traffic flowing to target 1. If we want to cut off everything from flowing to target 1, all what we need to do is reduce this one to 0. 0% means no traffic is flowing again to target 1. All the traffic is flowing but to target 2. And when all the traffic is flowing to target 2, let's consider this one to be target 2. When all traffic is flowing to target 2, you can now update target 1. When you update target 1, nobody will find out that the traffic ever stopped. Okay, while you are updating target 1, all traffic is being saved from target 2. Okay, when you finish updating target 1, what do? You simply restore the traffic, but while restoring the traffic to target 1, you cut the traffic from target 2. So target 2 have no traffic flowing in target 2, and now all traffic is flowing to target 1 here. All the traffic is flowing now right back to target 1. Now you can update all the instances that are in target 2. Okay, now if you were interested in doing but canary deployment, now let's increase this number. If you are interested in doing canary deployment, let's increase this to 10 and also increase this to 10. You discover that, okay, in canary deployment, this is a 50-50 deployment. Okay, now but when you want to update one side, you can first of all cut all these to 0, and all traffic is going but to target 2. Now as all traffic is going to target 2, you update target 1, but when you update target 1, you do not give 50-50 traffic directly to target 1. No, what you first of all do is you give maybe 16% to target 1, so that target 2 have 83%, target 1 have 16%, and then you weigh it out and let this 16% of people that will use the new version, let them see whether everything is good and fine and nobody is complaining. As nobody is complaining, you keep up increasing to 23%. Nobody is complaining, you increase to 28%. Nobody complains, you increase to 37%. And at one particular moment, you will have some sort of a 50-50 percentage here. You keep increasing, you have a 50-50 percentage, which means the new application is now having the same value as the old application. And then you discover that people are loving it. You keep increasing, and you see the old application is reducing. The old application is reducing as you are increasing the new one. When you get to 20 now, you start reducing the new one, reducing the new one, and the new one will finally get totally reduced to 0 and then be updated to the old one. The old one will get reduced to 0 and then be updated to the new one. When it gets updated to the new one, now you can restore back traffic to 50/50. So that is how you perform blue-green and canary deployment with your AWS platform. Okay, I hope this if you were able to go through the whole of this project and you are able to practice this project, I bet you if you are capable of understanding the whole project, you can put this project in your resume and you can say that you can develop a full-fledged, highly available infrastructure in AWS, which is dynamic and smart. Okay, so with that, guys, thank you very much for following the process right up to the end. We will keep trying to make good videos and create projects, to get projects that involve real-time with real-time code. It is not that easy. So thank you very much, and subscribe and like if this project was nice to you. Thanks and goodbye.
We the best, nigga, we the best, man.